Chapter 10, Section 2, Rates of Nuclear Decay. The first thing for today is half-life. It's the time required for 1/2 of a sample of a radioisotope to decay. Unlike chemical reaction rates, those that vary with the condition, so depending on maybe the temperature, the weather, the humidity, things like that, the nuclear decay rates are constant. So think about medications that you've been given or that you may have to take. All of those have a half-life, so it doesn't matter what the temperature is outside. Within 4 hours, it will decay, or within 2 hours, it will decay. So a way that we calculate half-life is we look at the number of half-lives elapsed by taking the total time of the decay, dividing it by 1 half-life. So for example, if I tell you that we have M&Ms and the chocolate stays in your system for 15 minutes before it cuts in half. Well, after 45 minutes, how many times has it cut itself in half? And the answer is 3. Now, likewise, if I was to ask you, what is the half-life? I could give you the time of the decay, and I could give you the number of half-lives that have elapsed. Or I could give you the time of 1 half-life, how many have gone by, so you could give me the total time of the decay. So we are going to be looking at that when we do radioactive dating for your lab. And radioactive dating is just a way to say the age of an object, and how that's determined is by the carbon-14 levels that's in the object in comparison to the carbon-14 levels that are in the atmosphere. So right now in Franklin, there's a specific number of carbon-14 level in the atmosphere, and for anything that no longer exists, or for anything especially things like trees, you can look at the age of that by comparing the carbon-14 levels that's within that object to what the surroundings have. We also call this carbon dating. Now the last section, Section 4, we are skipping Section 3, is fission and fusion. So what we have to have in order to have fission and fusion is a strong nuclear force, and it's an attractive force. It's binding protons and neutrons together in the nucleus. Now this is going to help either to fuse things together or to split them apart in fission. Now the shorter your distance, the closer things are together, the stronger the force is going to be, the harder it's going to be for things to be pulled apart. So fission, it's the splitting of an atom into 2 parts. Lise Meitner, from 1878 to 1968, so she was 90 when she passed away, was one of the 3 leading scientists who discovered nuclear fission. So keep that in mind. That's very important for you to know. Fusion is the opposite. Fusing is the fusing of 2 nuclei, so the combination of 2 smaller to form a larger nucleus. And that's it for Chapter 10.